Interestingly, if we look at it, design. So let's come back to when we are looking at and define whatever we have looked at till now. When we say about a project, now think about you doing a project or you are learning a subject in class. Let me give you an interesting example. And this example is real life. Many of you would feel, how do I apply? How do I apply design and innovation to the subjects that I am learning? A small example, in the first year, there is a topic in electrical and civil where they are talking about lighting. And in the lighting curriculum, there is a specific topic talking about lamps. Now, when you look at lamps, how do you apply design? And let me share here real life. So when we talk about a real life example, in this case, what are we talking about? We are talking about, here is a problem that you have to look at lighting and you have to look at lamps. Now let me ask you a simple question. Whenever you look at a lighting or whenever you look at lamps, what comes to your mind first? I believe that whenever we look at lighting, the first thing that comes to our mind is how beautiful is the lighting, how beautiful is the bulb, the shade, because we are talking about lamps, and therefore we talk about how beautiful these lamps are. And therefore, the lamps got more beautiful and were held as chandeliers or lighting fixtures in the home. But if we were to come up with some kind of an innovation which could be called radical, here is an example. There is an organization, Artemide International, which is based in Italy, and they specialize in making lamps. So when they got this thing that we want to create a new kind of lamp, and this was people who did product development and engineers like you. So when they looked at the lamp and the problem, they didn't look at how does the lamp look. They went into what does a lamp do. So the function, and the lamp they realized is giving light. So then they looked at, can we look at a different aspect? So they talked to various architects and they talked to various interior designers, and then they realized that light could have different effect on human beings. So a red light could have a different impact than blue light and a green light. So they said, let's look at this concept rather than creating a beautiful lamp, let's look at lighting and its effect. And then they came up with a product which is called Metamorphose, which is the name of a lamp. And this lamp does not look good at all because this lamp is not there to be seen. This lamp is kept behind a desk or behind a bed, and it just throws up light, and that light is based on the mood that you want, so you can adjust the light accordingly and set up your mood accordingly. So what happened here? I am sharing that you have a project, you have a small you have a subject there which is covering this topic of lamps, and if you bring in design to this aspect into lamps, here is someone who created a completely original lamp. That is how you use it. So this was one of the example that how do you use design and innovation to bring in your subjects, the subjects that you are studying. For example, you are studying engineering drawing. In engineering drawing, the two of the most important aspects are you able to see things in 3 dimensions in your mind? If you are able to see those in the mind, the next thing is to put it on paper. And this is where it is very difficult for engineers, because they may get some brilliant ideas, but they don't know how to put those brilliant ideas that they have in the mind on paper. And that is where you use engineering drawing and the both abstract, which is your 3-dimensional understanding of the world, and you bring it to the real, which is on paper. So engineering drawing as a subject has such a beautiful implication. Now just think about it. How do you apply design to engineering drawing? And it's a simple thing. Look at the world around you. And how can you express that world by simple sketches? So I'm not even saying that you make some very precise and perfect drawing there. That's of course required in engineering. But what I'm saying is, can you bring your idea to paper and using engineering, design and drawing? So you see, in the first year itself, whenever you come across the subject of engineering drawing, you could approach it from an aspect that it is both the abstract, because you want to see the intersection of objects, how they happen and then represent it on paper, that is one part. But the other part besides seeing is how do you visualize continuously. So you look at a mobile phone and you want to come up with a newer kind of mobile phone, or you want a television which has to be designed differently, or fundamentally a new product to be created. How do you do that? You visualize, it comes as an image in your mind, but unless you put it on paper, how are you going to explain that to others? So here were two example friends, because most of the time we realize, how do we implement what we are learning in the subjects in the classroom? I could give you multiple examples. For example, you could easily look at mathematics, and when you are looking at calculus and trigonometry, you could very well understand that there is Fibonacci's law and rule, which is very easily talking about minimizing of spaces. And when you learn that from a perspective of an engineer, you understand the concept, and then you look at how are these put in a spiral way, how does it happen in nature. So you look at a sunflower, or you look at different flowers, and you see how that rule is applying there, and you bring that back in your engineering application. So it could be greatly useful for civil engineers to do construction in a different way. Or it could be very well even used by electronic engineers, because that's the best way in which things can be fit in a certain limited space. So if you have to fit in the various components of your electronics device in one box, that's the best that we can learn from it. So that's why, friends, we were talking about, these are the few examples which are very easy of the first year, how design could be brought into the classroom. It's only a difference in the mindset. So when you start to think differently, and when you start to look out of the box, that you start to realize that you have so many applications from real life. So to go back to the presentation, when we look at the first aspect, it is contextual, real life. The second is in-depth study of user, which we have seen. We looked at a product study, that how the products could be developed. We looked at prototyping, which is rapid and conceptual. Collaborate with other departments, disciplines and industry. We looked at that aspect. Moving ahead, creativity. Now this is one of the most interesting domains, and people say I am creative or I am not creative. But it is not about being creative. Every human being is creative, and every child born, as Picasso used to say, is already creative. We remove the creativity out of the child by bringing logic and the left brain thinking. So here I would like to share that creativity is simply finding multiple solutions to one thing, and that you could easily learn by some exercises of lateral and divergent thinking. The other aspect is the purpose. So being clear about the purpose, why you are doing the problem, why you are doing this specific work, what kind of problem are you solving. If you look at a project, what is the problem that you are solving? That's the basis. How do you define a project? So you look at the project from a perspective of what is the purpose of my doing the project. And interestingly, I would like here to stop for a minute, that of course we are doing the project to get more marks, but along with that, I would add, are you looking at only more marks, or are you looking at more money? Because more money is what you will get when you get a job. And how will you get more money? If you are able to convince the people who are going to recruit you that you are different from others and you have different ideas. So here it is a very interesting thing. Each one of you could be doing your project in a different way and come up with different product, and you could share that with the industry, is originality. And think about it, if you are that kind of an original thinker and a problem solver, you have increased your worth in the market. So here is how you are using design and innovation to directly apply in your life and take your career a little higher by using these techniques. Now let's get back. It's learning by doing. It's very important to understand here that most of the things that we study sometimes comes through books and audio-visual material. But unless we apply whatever we are doing, so even this session that we have here, if you have just listened to it and you say, okay, I understand, I don't think you've understood anything, because you have to apply what you have understood and you have to do that and do it by your projects and the subjects. Like I gave 3 examples, you can apply design to those subjects and come up with your own interesting exercises and solutions, and that is hands-on. Another very important aspect is change management, because when you are going to do this project, a lot of people will come and say, why do the project? We can easily borrow some project, or we could get some project from somewhere, and we can manage to do shelf project. But interestingly, if you are standing on that criteria, it's very important for you. How do you manage that change? How are you able to convince others that no, we don't want to copy anything, we don't want to do shelf projects, let's do original projects. They could be small projects, but we could do original projects of our own, and that's change management. Because you'll have to talk to a lot of people to do that. You'll have to talk to your friends, your parents, your teachers, and the other people from the industry, and you could talk to the system that here is something that I want to do originally. So your project could be an original project that you could do. That is where you have also to know that not just the process and the tools, but you should also be able to manage the change. Can you bring that change in others? Can you make a change in their thinking, that they start to think like you and develop original products? That's what we are talking. So change management. And the final aspect that's very important, friends, is we have lost the joy of learning. The joy of learning has actually gone out of our life, and therefore the last aspects I would say is celebrating innovation. So whenever you come up with a good idea, it's very important in a group of friends to celebrate the same. I'm not just saying that you celebrate the patent. That's of course it's a celebration time, but you also celebrate your small successes on the way, and that's because innovation comes about from motivation and celebration. So if you are going to create a culture in your college for design and innovation, please see that you also celebrate the same and share it with others. So that's what we have looked at till now. Now we come to the kind of projects that you do in your classroom. So if you look at the kind of projects that you do in your classroom, generally these projects fall in these categories. Either they are hypothetical, which is theoretical, versus real projects. So some of you may pick up theoretical and some may pick up real projects. Others may look at internal versus external. So sometimes the problem is internal, so you find out a problem from around you, and sometimes you get a problem from outside. How do you mode of sourcing a project? Sometimes you find your own answer, sometimes you look at from faculty, or sometimes you look at from industry. The other aspect is number of interactions with mentor. So do you have a mentor from the industry and from the college? And is the mentor able to help you to go to the next level? Now here, it is a very simple thing of networking with people to have mentors. It's not necessary that you need to be constrained that in my college my teacher can only be a mentor. It could be a mentor from the industry that you find out, or it could be somebody from another discipline. So it's not necessary that your faculty and the mentor are the same people. You could find your mentor anywhere. So that's the aspect. The type of interaction. What is the kind of interaction that you want to have with these people and with your network, so that your product or that you are creating remains original? And if we move ahead from there, what are the constraints? Generally, when we look at engineering projects, the constraints are the number of students in the class and therefore the number of projects. And straight away linked with it is how much time should mentoring take place. So the time as a constraint is the next one. And the final is industry interface. A lot of students come back and say that I don't have a proper industry interface. Looking at all these constraints, we came up with a framework, and this framework has looked at all of this. So if you were saying that these are my constraints, we have looked at these constraints, and the framework we are going to discuss right now is going to talk about these constraints being addressed in the framework. So you are not going to then worry about that whether I get mentoring, how do I get mentoring, whether there are resource constraints. All of these factors are looked at in the framework which I am going to present to you right now, which is Design Driven Innovation Framework for Academic Projects. Further, if we look upon the constraints, it's very interesting. very many times a lot of students come to us and say that they want to do a project which is new to the world project. Otherwise, they don't want to do anything. But let us understand here, the new to the world projects or new to the world products come once in a decade. It may come in once in 5 years, but they don't usually come every day. And therefore, if we understand that if we have this approach and mindset of new to the world projects or nothing, then sometime we land up with nothing. And that's where I would like to highlight that please don't look at that always you need to come up with path breaking projects. No, that's a mindset. You may come up with, you may do a lot of ideation and come up with multiple projects, and some may be only an application. So it is not necessary that you come up and say that my product will be the first in the world. No, sometime it could be the second, but it could have a different application for different people. So please don't be constrained that your project has to be only an original project. It is not necessary that it has to be an original. It has to be your original. It cannot, don't be stuck that it is new to the world. If you come up with your original thoughts in an academic environment in your college, it's very well. Somebody may have developed that same product somewhere else in the world, and it may not be new to the world, but you have solved a problem for the industry around you. So that's what we are talking about here, is a mindset change. The culture of innovation versus academics, and I have given some thoughts on that already, that how do you earn more and just not focus on marks. Marks are very important, but how do you take those marks and make it to your advantage by using innovation in the work that you are doing in your engineering college? It could be in the subjects you are doing or in the projects that you are taking up. And the last one is one-time brilliance versus a systems approach. So when we were talking about that, we were looking at one-time brilliance. It normally happens in an engineering college that a lot of young people are talented and they come up with brilliant ideas on their own. But how can you transfer that idea to somebody else? Or can you do that again? And that's where the constraint sometimes is that we are brilliant only once because we have not followed a process. We have not followed a system. And that's where this is one of the constraints, and that is being addressed. So these were the constraints that we looked at. Now we move ahead and look at innovation.